it's another top 10 list. It's an answer to the OWASP top 10, which is a list of risks, right? A list of security risks, really from an attacker point of view. The OWASP proactive controls is a defensive top 10 list around the same subject matter from a programmatic defense point of view. This is not a standard. This is just another top 10 list to spread awareness to developers about application security. We'll look about defining security requirements, leveraging different frameworks for security, secure access to our database, encode and escape data.
Stop injection, input validation as good hygiene, implement digital identity, next generation login type mechanisms. We want to enforce good access control, good design, protect data everywhere in transit and storage. We want to implement security logging and monitoring, so our security teams in real time know what's happening in our app security-wise. We want to handle errors and exceptions in a granular fashion. That's where we're going in this presentation. Let's do this. Let's start with
the OWASP Foundation has a standard called the Application Security Verification Standard. This is basically a list of about
260 or so requirements for developers that define what security is for an application. And this standard's broken up in 3 different categories, 3 different tiers. One for every app, a second level for like sensitive data, and a third level for like critical and infrastructure applications. So you can start with the level 1 requirements, work your way up over time, depending on the kind of risk profile you have in your app. This is an example of some of the requirements. Verify that communication between application components, including APIs, middleware, and data layers, are authenticated. Components should have the least necessary privileges needed. So that's talking about like in a microservice hierarchy of all these different services. We want to keep verifying authentication with each hop throughout the application. That's what this is trying to say. But the point is
that now we have a clear definition of what a secure piece of software is on the web. There are several several break-off standards like the MASVS for mobile development. There's an IoT ASVS and others being worked on. And the idea is not to follow these requirements exactly. We want you to
fork this for your team, and customize it for your specific organization or app. Whatever standard you have is better than what we usually do now, which is a little bit free for all when it comes to security. A lot of us will scan and fix bugs. We want to take a more proactive approach.
Customize this for our individual organization. We might use a certain identity service or have a certain access control design or other procedures and policies around privacy. We want to make sure that those custom requirements about our organization is a part of our standard as well. So the real point
here is to take the ASVS standard and fork it for your organization. That's the real purpose of it in my mind. The other piece of this is, again,
several of the things that we want to tailor in a set of requirements is, again, how authentication or your identity service is going to work, or the access control policy, or any rules you may have about validation of complex data, or a certain standard on logging. Whatever that is, the more detailed your standard can get, the more developers can act upon it. And the whole point of this first one, I know it's kind of a soft entry, non-technical, but developers are almost never given clear security requirements
at the beginning of a project. And they're usually given general guidelines or tools, or like maybe have some policies and procedures, but really clear requirements on what expected around security. I almost never see that. This is a mammoth failure of the SDLC. So let's get more technical though. As we go a little bit deeper into the open We want to have to rewrite the wheel every single time when you do security. We want to leverage what's out there. And when we start using different frameworks and different libraries for security, the biggest responsibility we have is to keep.
This is the last time I was personally doing a lot of coding a few years ago in the Java ecosystem, and these are all the components I was using. I was using Apache POI to read Microsoft files, and that's vulnerable to XXE. Same thing with Adobe's XMP toolkit and Apache Struts, really big deployment environment, application server for Java that had remote code execution in 2015, in 2016, in 2017, 18, 19, every year.
Something with Struts comes out as a problem, so I'm constantly patching it to keep it up to date. And then Jenkins. This is one of the key components for the DevOps movement about developer security automation. So that infrastructure itself is constantly filled with critical security bugs as well. And so when we're using these third-party components for security and development, we have this massive responsibility to keep it all up to date. What do you think our response time should be, audience members? When we have a third-party library, how often should we check our application to see if the third-party libraries we're using are up to date? How often should we check on that? What do you think up front? What do you think? Just go for it.
Hopefully it's automated so that it's like notified, it's more reactive. Like you get notified that it's
so yeah, so you're saying is I don't want to have to scan for it. I want it to be reactive. So as soon as an insecure library is found, I'm alerted. That's how GitHub rolls. If you're a GitHub developer. So if you're doing your own build environment. Anybody else? I love, by the way, that's a A+ answer. That's fantastic. What else? What else is out there? How often should we check our code base for third-party libraries? If we're doing more local development in our own Jenkins environment, how often should we check third-party libraries for security? Like 100 times a day? That's kind of what I'm thinking. Like every time a developer compiles, every time we build, every time we touch the code base in some way, we want to run testing to check for third-party library security. The other big piece of this is what if it's legacy and we're not developing anymore? We want to have some kind of offline process still. Even if you're not developing, it's good to keep an eye on the code base. Even as it gets into sunset mode or we're retiring it or not working on it, we should still be checking for security on a daily basis. Remember how I said Struts had some major vulnerabilities on a yearly basis? Anyone know why this CVE 5638,
remote code execution, otherwise known as command injection on Apache Struts 2. Why is this significant to all of us? Yep, that's what took Equifax down. And so it's one server not being patched. So a few notes on third-party libraries is we have the
OWASP dependency check project.
This is like a developer automation project that can look at a variety of different code bases, looking for a variety of different languages and frameworks, looking for insecure third-party libraries. In Java, I also
like to run Maven security versions at the same time. There's also RetireNet and dependency check for the .NET world. JavaScript is freaking insane, but there's NPM audit, which is built in NPM, getting much better by the day. NodeSource has a list of trusted modules as a commercial offering. I'm not trying to sell NodeSource. It's just compelling, the idea of a trusted repo that's already been heavily reviewed for security that we offer to developers. I also run a plugin called RetireNet.
This is a lot of fun. A lot of very popular websites use jQuery, and almost every version of jQuery has vulnerabilities in it right now that are unpatched. So I digress. So virtually every app has this issue. Every app has this problem, and it's not always easy to solve it in certain environments.
Where it's built in and integrated as a solution in other more mature environments, but it's something we have to handle. I see this as the #1 issue that's out there right now. Because even using the best of breed tooling, do you think that the alerts that we get tell us about all the vulnerabilities in the third-party library code out there? It's not even close. Ron Paris was looking at the React world in 2018 and found 3 bugs in React third-party modules. Guess how many bugs were reported in React in 2018? That'd be 3. And what that says to me is the JavaScript ecosystem, as well as others, there's massive amounts of insecurity out there that no one's looking for or reporting on. We're just using this stuff blindly, hoping it doesn't have a security problem, and depending on other researchers to find bugs for us and report it to us for us to be secure. It's not working. There's so much third-party library code out there that even if the dependency checkers don't tell you there's a problem, I would still keep all of your code, all your third-party code, up to date at all times. This is not easy to do, but the point I'm trying to make is the third-party checkers only address part of the problem. And so there's a lot of bugs being fixed already reported on. So keep your libraries up to date at all times is really the leading edge of
how to solve this issue. Let's talk about securing database access. This is pretty basic. We're talking about SQL injection. Anybody know when SQL injection was first discussed? This is December 25th, Christmas Day, 1998.
At a Usenix meeting, Jeff Forrestal first dropped the term SQL injection. How do you stop SQL injection? Anyone know the right defensive strategy to stop
SQL injection as a developer? What's that? Yeah, that's exactly correct. It's a parameterized query and using bind statements. That's the right answer. A lot of folks who are not as wise and brilliant as you are, sir, would say input validation, right? Have you heard that answer before? Just validate your data before you put it in a query and you're all set. Have you heard that answer before? This is not right. This is not a good answer. For example, what if you're going to do
validation of an email address? Like I'm in my account profile, I edit my account profile, and I can edit my email address. And I send an email address to you, and you're going to validate that it's a good email address, right? You're going to use it for security. Would this be a legit email address? Is this a...
What do you think up front? What do you think? I don't do no scanning. I wait for them to tell me. Yeah, exactly. Is this a legal email address? Yeah, it is. It's crazy broad, but this is a totally legit email address. Not only is it legit, it's active. So you can send me email here and I'll reply with
one word, believe it's real. And the whole point is, if you're going to put that email address in a database query like this, I'm going to select some data from my customer table where the email is, that email we just entered in, right? If we just validate it for security, there it is. There's a final query. Select data from the customer table where email is Jim or 1 does not equal manico.com. This is always true. This is never equal. Or true will cause this email check to just be ignored. Because is that true? Is that true? Or true, the entire customer table will get dumped from a legal email address. So we got to parameterize our queries. By the way, there's SQL injection in code. You see the vulnerability? Anytime you're building SQL, where you're building it with string construction, that's SQL injection in code. What we want to do is we want to parameterize our queries. You ready for it? What's your language of choice? Call out a language. What do you like? What do you code? I don't like Python. So, no, I'm only kidding. Okay, I'll give some props to Python. Python has a library called diffused XML, which is an XML parser abstraction that turns off all the different dangerous XML features. It's an example of a best practice I don't see anywhere else. It's really good. So where am I going? Yeah, we have let's do some HQL. Let's get obscure. So here's like an HQL statement from Java using Hibernate into Hadoop. So I'll say from the inventory objects where the product ID is a certain value, there's OQL, object query injection. We want to parameterize the product ID and bind the data from the user to that product ID. Injection goes away. We have this also in C# for you .NETers. C# is really mature these days. I'm a Java guy myself, but I got to admit, C# has come a long way. So select from user where the name is name and the password is password and bind that data into our bind statement. SQL injection goes away. You get performance benefits. There's my world of Java. We'll go Java, update the employee table, set salary with our question mark placeholders. There's our bind statement. Go query parameterization. I know you're shocked at how exciting these code examples are, but this, and by the way, sometimes you can't parameterize, right? We're talking about SQL injection. We're talking about using query parameterization. Now we're talking about where you can't apply parameterization, like a table name or a column name. If you're parameterizing a table name, it's probably some weird design. It's a design flaw usually. And if you're parameterizing a column name and an order by or similar, we just want to like do some kind of lookup map. I usually have the user pick a number in my code that maps to a column name, which I safely add to the query from a trusted source. There's a couple cheat sheets. We have the Bobby table, shows you how to do SQL injection protection in many languages. There's a query parameterization cheat sheet, and it's this ASVS requirement number 5.3.4. So there's a documented standard that we talked about earlier that points to SQL injection defense. All right, we're talking about the OWASP proactive controls. We're on control number 4, and when we're building a secure user interface, we want to apply some kind of escaping library. Yeah, look at you Python people. You got the Jinja 2 framework, you have the markup safe library for HTML sanitization. This is pretty legit. So almost every language has some kind of escaping capability. And what we really want to do is use technology like Go templates or React or Angular, which do a lot of the escaping for us. When we escape attacks like this is a cross-site scripting attack that gets added to a user interface in some way. And if I escape this attack, all the dangerous characters get neutralized. And then the attack will render, I'll see it on screen, but it won't actually execute the attack. And this is a big part of cross-site scripting, user interface security, and building web applications. And just here's a little additional escaping. Here I am building an LDAP query to talk to an old school authentication system, and I'm escaping all the dangerous characters that could change the command. I also have really specific escaping for distinguished names in LDAP. So this just shows you whenever we're trying to stop injection, very often one of the defensive strategies is escaping dangerous characters. OWASP proactive controls. We're at proactive control number 5. It's about input validation now. So the basic rule is that every piece of data entering your software, regardless of the source, should go through some kind of input validation layer. A lot of the fields that we don't typically type into as a user often are less prone to validation, like a cookie value or a header or a hidden field or something like that. That's just part of the app, not something a user types in. These are often less prone to validation. And there's like 3 kinds of validation we want to do. Sometimes we want to do exact batch validation when there's a limited list of choices. Most of the time we want to do known good, whitelist validation, to like define a pattern of what good data is, reject everything else. Sometimes we're looking for specific attacks, or we can pick up places in other validation code that we know only an attacker can get to. Well, let's look at that. Let's do that. Before we get to other validation rules, in a lot of my code, I don't do validation anymore because I'm supporting so many international languages. So at the very least, I do length checking. I make sure that all the characters are printable, not a control character. And then I check to make sure that the field that I'm about to put in my database or similar is limited by a certain size. I have to do at least this. Other kinds of special validation are like validating URLs to secure open redirects. I want to make sure that the URL either exactly equals what I'm expecting or starts with the HBS scheme, manico.com, and a slash to limit all that URL to my specific domain. So here I am doing URL validation deep in React itself. I want to avoid JavaScript URLs. I want to avoid data URLs on the web that cause cross-site scripting, cause JavaScript injection. So I'm checking if the URL is HTTP or HTTPS only. So when I render the link, I'm only going to render the link if it's a safe protocol. If it's JavaScript as a protocol, I'm not going to render it. So there's another kind of specialized validation. That was a little bit circuitous, but we're in the OWASP proactive controls. We're now talking about control number 6, implementation of digital identity, like handling login systems. What is authentication, first of all? Well, I just said it here. It's identity, duh. It's establishing who a user is, right? That's all it is. It's establishing that someone is who they claim to be. An authenticated session is an area of memory on the server that we use to track if someone's logged in. And a lot of the server-side sessions is going away in modern development. A lot of us are moving to JSON web tokens that are stateless and depend upon a digital signature to make sure they're not tampered with. Anyways, I want to talk about modern password policy. What do you think a good password, what do you think a good policy is for a password these days? Anybody want to chime in before I go down my rant on passwords? I love to rant on passwords. I'm sorry?
So we're told it should be long and have uppercase, lowercase, different characters. longer it is, better it is.
And please
Change
make
it every so often.
please make it unique for every single website too.
Yes.
It's got to memorize. On average, people have about 90 accounts on the web, so please give us 90 different passwords you got to remember.
Right.
Is that cool?
Yeah, that's what I've heard.
Yeah, did I get that right? This is nuts, right?
Yeah,
So there's a new standard from NIST, which is trying to change this. They want to set a whole new set of rules on what a password policy is. This is NIST Special Publication 863B, the new digital authentication guidelines. They want to change the burden of the password onto the verifier and take some of the burden off the user whenever possible. So rule number one, don't limit the characters of a password. A password should contain literally any printable character should be acceptable. Number two, the size should be at minimum 8. We kind of disagree at the ASVS standard, but this says 8 characters are just fine, especially if you're also using multi-factor. NIST asked us to block passwords that are contextual to our service. Like a password shouldn't contain the word password because it is a password field. It shouldn't contain the name of our business or the type of business. And we want to have like 10 to 15 context words that we want to look for and block out of a password. Next, we want to check against a list of common passwords. This is often how brute force attackers go after an account. They know if the attacker knows a username, they'll try a large list of common passwords, the most common passwords that would normally fit your policy, and use a large number of those to attack an account with an intelligent word list as a kind of brute force. And so when we're building our own authentication system or using an authentication service, there should be a capability to block the top 50 to 150,000 common passwords used in the world today that would ordinarily fit your policy that we want to now block. Daniel Miessler and some of the bug bounty folks have a SecList GitHub page with these millions and millions of passwords in various lists that you can use to feed your own systems. Next, we want to block a list of username password pairs. So this is called credential stuffing. It's a relatively new category. And what they're suggesting here is that there's been about 7 billion username password combinations leaked to the world in breaches in the last 10 years, like LinkedIn and eBay and like Yahoo and many others, about 7 billion accounts altogether. And so whenever someone tries to register a new password, new account, or tries to change the password, we want to block the use of known username password pairs. And there's different commercial services you can connect to do that verification. We also want to have multi-factor in play. I mean, we've known about multi-factor well over a decade. It's meant to stop brute force and other attacks against your password. And so having multi-factor is a real must-have these days. And every year I up the heat a little bit. I used to say it's nice to have. 2019, I mean, this is really a must-have for any kind of application that contains private data that you don't want leaked. And if you're public data that you still want authenticated for accountability, then a password alone is okay. But as soon as we have private data in an app, NIST workflows say it's time to at least have some kind of multi-factor, like cryptographically generated value. I digress. I get off getting all excited. All right. So they also say don't have email addresses for a username, since email is a public piece of data, anyways. And also, if a large website gets breached, we want to make sure that when we see a breach from a major website, we take the usernames that were part of that breach. If they match the usernames in our website, block those accounts and force password reset on their users is a practice I see many of my customers. That's to stop credential stuffing.
So I have a question, sorry. So we know if your account gets hacked, what is the policy on your username and your email? If that has been exposed, how is it imperative that you get rid of that whole username or email? Because people end up, including unfortunately myself, end up using the same username for a lot of different accounts, but like different passwords, of course. But is that not a good policy?
I'm less concerned about you changing up your username. I'm more concerned that you use like a password manager to give each of your accounts a really strong, unique password. If that's what you're doing, you're in good shape. And it's even better if for all those accounts that do have a unique strong password, you also enable multi-factor, you're really in good shape. Now, that aside, there are some sites that are very obscure in how they deliver, that give you obscure usernames on purpose. Yeah. Like I've done institutional Bitcoin trading for big companies, and when I built an account for them, I can't pick my username. They'll assign one to me to help make that account unique and strong. That's not a bad practice for banking and other, high risk software that you're using. It's not a bad practice at all. And on that note, letting a user, as a user feature, let them change their username, or even better, a suggested username for them that's strong is really not a bad idea.
Yeah, that makes sense. Thank you.
Also, throttle brute force attacks. Address brute force in some way. Throttling, slowing down the attack, but letting a good password in fast is usually the best way to handle that. Don't force a natural password special character rules. Uppercase, lowercase number, special character, get rid of that. This is very controversial. I think it's a good idea if you do everything else on this list well. Don't use security questions or hints. I can look them up on social media. No more mandatory password exploration, because you'll do password 1, password 2, password 3, and have the sequence anyways. And allow any printable character, including emoji, spaces as well. This is a bad password because it's got the word password in it. It's only 10 characters. It's one of the top 50,000 passwords in the world today. It's like 31,000 in terms of commonality. So there's a lot of reason why this is a bad password. I think you want to hear about password store. Anybody care about how to store a password within your system? Want to hear about that? I'm going slow today. I'm in LA. I'm more chill today. So I'm going to give you one important piece, which is use bcrypt, scrypt, or argon2i. Use the right algorithm. They all have at least a time cost, and I recommend like bcrypt with like a work factor of 13 or more. And what that means is when you're gonna do hash tracking, when someone has stolen your database, if you have MD5 as your storage mechanism, it's about 200 million attempts per second on my laptop. You got SHA-1, 68 million, and bcrypt with the recommendation work factor of 13, it's only 380 per second. It really slows down the attacker who's stolen your database and is now trying to uncover your password based on bcrypt storage. The slower you go, the more time you can handle, you can use to manage a breach. And so this is a ginormous topic, identity. ASVS has a whole section 2.1 on this, as well as an authentication cheat sheet. And your homework, what's your name? Mister, I don't want to do scanning. I want to be told when that's a problem. I'm impressed with that answer. So this is your homework. It's go read NIST 863.3. This is the new digital media authentication guidelines. There will be a test. So just tell me when you're ready. All right, let's move on. Moving on. So we're looking at OWASP proactive control number 7. We want to enforce access control. How do we hack this web API? Is there water? I'm begging for water. I forgot to bring water. Is there water? Grab one. Here's a URL. That's a mail message system. And here's a URL that you're using to read one of your messages. This is not a hard question. How do you hack this? Yeah, punch in random numbers. How long would it take you to write a script to try every possible number here? 5 minutes. Are you full-time or are you a contractor? No. You're a full-time. See, if you're a full-timer, that's a 5-minute project. You're my hero. Thank you so much. If you're a contractor like me, it's at least a 2-week project. Cheers to you. Let's get to work here. Thank you very much for the water. So this is the normal query behind this. This is vulnerable to direct object reference and access control level vulnerability against this. But if I add an ownership reference in, select message with a message ID is a certain number, and the owner of that message is the user ID, which I pulled from Session. That's a trusted location inside of my app. Then the database is only pulling down messages that I own, and that protection is built at the data level. And overall, I recommend that you move away from hard-coding roles, role-based access control, to move to a more attribute-based access control system, otherwise known as permission or activity-based access control. Here's some homework. We have NIST 800-162, the new federal standard, but not new, a couple years old, federal standard on next generation access control design, as well as the access control cheat sheet at the OWASP Foundation. So C8 says protect data everywhere. Now that's a tall order, but let's do it. So essentially, how often should we be using HTTPS in web and API development these days? Is there ever a good reason to use HTTP in our work? Yeah, even then I wouldn't do it. You know, it's because, especially if it's in a cloud environment, what's on the same box today is scattered across web services tomorrow. And we can split hairs. I hear what you're saying, but as a new norm, as a default, we really should use well-configured HTTPS pretty much everywhere at this point. And so we can also use things like strict transport security with this technique called preloading. This is a response header that tells the browser, my website is only accessible over HTTPS, and you can actually submit your website to the Chromium project to say that your website has to follow certain rules of play, like have the word preload in the strict transport security response header. That's more than a year's worth of time. And if you follow that right criteria, they'll actually hard code your website into Chrome, Chromium, Firefox, Safari, and every other major browser that has a rule that says your website is only accessible over HTTPS. This is again called strict transport security preloading. It's the highest form of configuring a website to be really strong from an HTTPS point of view, I would dare say. Also, if you're going to do cryptographic storage, then I recommend, first of all, what's the hardest part of a stored crypto system? It's usually where do you stick the keys? Where do you stick the keys, sir? Who knows about query parameterization? Let's go behind door number 2 now. What do you think? Where should I stick my keys? That's a great answer. That's a form of secrets management. Boom, number 2 out of the park. We want some kind of key vault. We want some kind of secrets management solution. And the old school way to do this is a straight up hardware security module. You're basically setting the key in this specialized piece of hardware and locking it so the key can't even be extracted from the hardware. Then you send data into your HSM. Encryption happens in a sealed environment in the coprocessor, and then the encrypted data is returned where the key was never exposed to my code. It's one of the ways you can run an HSM. So we see a lot of payment processors use technology of this nature. And for your development, there's a project called the HashiCorp Vault, vaultproject.io. There's an open source commercial version that you can hook up to your server as a form of secrets and key management. Also, I highly recommend you don't do your own crypto in code, right? Don't use Java. All working right now, it's got all the best practices of crypto embedded in it. It's a real simple to use API, and it has direct integration with key management, like Amazon Key Management Service, or GPC's Key Management, Azure, or HashiCorp has direct integration in the library itself. So all the difficult problems, key lifecycle, the problems with what algorithms to choose, solved and well chosen for you. You're going to have a much better experience of using libraries like this. If you're deep in C land, there's libsodium from University of Chicago, Dan Bernstein, another really good best practice library. And this is not easy, right? So we have a couple cheat sheets, transport layer protection cheat sheet, cryptographic storage cheat sheet. I gotta mention SSL Labs, they got their act together. Great documentation on best practices for HTTPS configuration. Oh yeah. We're in the proactive controls. What are we talking about next? So let me see where we're at. We're at protect data everywhere, and C9, we're going to talk about implement security logging and monitoring. This is a very exciting topic. You're like, it's logging, but this is so exciting because it helps us do intrusion detection as a security professional. If there has been a breach, it lets us do forensic analysis in a reasonable way. And there's a lot of laws and compliance over our head that really force us to do logging in a certain way. There's a lot of good reasons why to do this. We should log early, log often, log both the request and response. If the response is missing, we know that the request crashed in some way. And what you really should do is work with your security team to define a clear logging standard and understand what the developer's responsibility is. That doesn't always happen. So at the very least, log all successful and failed authentication events. all events about how your front gate's working. Login failure, change password, registration, bad or good session IDs, everything. Log any access control failure on the back end of your system. When you have a feature, not like a server-side feature, how often should your user be trying to access it and be denied access to it? Like you have a feature like delete user. How often should you see users trying to delete user who don't have access to do so? Well, really never, if your app is written correctly. So if you see those events, you're under attack in some way. Also, any input validation failure, bad sizes, bad characters for certain fields, log all of that, lets me see when I'm getting scanned by attack software on a regular basis. If that's all you give me for logs, then I can work with that. Also, things to log, app start and stops. I don't know what outpost validate was this typo. So authentication failures, I mentioned most of this. Rate limiting actions from brute force, fraudulent transaction attempts as well. And also be careful not to log things like credit cards. I wouldn't log a raw session ID that lets anyone viewing the log hijack different accounts. I would log a hash of the session ID so I can tie certain logging events together without exposing the session ID itself. I can use that to hijack the account. I also recommend not logging data that's relevant to GDPR's 2 categories of privacy data. So you're respecting the privacy of your users if they're European citizens. And basically, if you don't need it, if any sensitive data, PII or healthcare information, if you really don't need it, then don't log it. Try to stick to security information. So there's a couple of cheat sheets, the logging cheat sheet at OWASP, to give you more information about these topics. A10 is about handling errors. I'm gonna punt on that for now. But the basic conclusion, how much is this a good wrap? How far along are we?
We got another 10 minutes.
10 minutes. I'll do Q&A. I'll wrap a little earlier. I'll talk about error codes. I'll talk about API error codes. Actually, let me do that. Let me hop out of here. So let's do the 10th category. Let's talk about error codes. This is a very exciting topic. So let's talk about like REST application development. Where do we have the REST error codes? Let's talk about one nice concept about handling errors in an effective way. That's right at the beginning of my presentation. There we go. Boom. So in REST development, for web service development, we want to standardize error codes on the HTTP protocol response codes. What that means is if there's an access control problem, we maybe want to say 401 unauthorized found. We all know that. Or like if maybe they're trying to access a feature they don't have access to, 403 forbidden or instead of 401. Now, there's all these, if I'm trying to like book an appointment that someone else grabbed a time slot for, 409 conflict. A lot of people don't agree that I should be listing all these error codes. What one of my customers does is the only error they will say is 400 bad request. Because they don't want to tell the attacker if it's an access control problem or if the resource doesn't exist or similar. They just say 400 bad request, then they log the more granular error code at the logging system as well. So that's one quick note about handling and managing errors within the world of web security, is that be careful what kind of error you give to the client. You may leak information that will help. One last information, the last idea I want to get across when we talk about application security, right? We really want to do 2 things. We want to develop secure code, and we really want to do testing on a very continuous basis using as much automation as we can. So I mentioned the ASVS standard, again, about 280 requirements for development. I recommend you fork this standard for your team or your organization so you all have a clear definition and a clear vision of what secure software is about from a developer's point of view. And what responsibility. Clients took like the 80 requirements from authentication and dropped them and just said, use our authentication service this way, and this document will tell you how to use it. And that was their whole set of rules on authentication. Done. So fork it for your purpose. Also, if you have more questions about different details about secure coding, the OWASP cheat sheet series is just that, a series of guides on how to write secure software. It's basically a living encyclopedia that's constantly edited by a series of experts around the world every day. Also, that's the main resources I look at myself for how to build secure software. Now I have to test on a regular basis to verify I'm doing it correct. And so we want to make sure that whatever tools you're using, they're being run on 100 times a day. And you want to automate as much as possible, as early as possible, as developers are doing their work every day, every check-in, every time they build, run a suite of tests for security that run relatively quickly. And then maybe once a day at the end of the day at night, run those same tests on full mode that goes slowly and maybe takes several hours to scan at night or on a periodic basis. So you have these two different wheels of automation running at all times. One running fast and furious, quick tests every time someone touches code, and then once a day or once every couple of days in a much more slow, detailed, full mode scan that a professional reviews on a regular basis as well. And that's like the engine of security testing that should be tuned engine, needs to be tuned by professionals on a regular basis. And this automation is going to miss things like business logic, access control. Like, what tool knows your access control policy? They don't. The tools just know about known vulnerabilities. So we want to also have penetration testers or custom unit tests, other forms of testing that can look for custom problems more contextual to your business or software. That's it for me. If any questions as we wrap up the OWASP top 10 proactive controls? Thank you. If you have questions for me beyond this presentation, I'm jim@manico.com or jim@owasp.org. Thank you for being here at ShellCon. Hope to see you at the pool party tonight.